Okay, let's get started. So, are there any questions about assignments or test or what? Cold weather?
When it comes to the test,
Yeah.
are we gonna, you said you're gonna have a sheet of paper for us with our names on it.
Mhm.
Is it only gonna be one sheet, or is it gonna be like multiple?
So,
Can we bring in our own?
so I mentioned last time that your name's going to be pre-printed on the test. So, I'll talk about this when we get closer to the test. But your test is not going to be stapled. So it's going to come, I believe, if I did it correctly, 5 sheets. So front, back, front, back, front, back, front, back, and then 1 extra sheet for rough work. On each of the sheets on both sides has your name and your ASU ID on all sheets on all sides. So so there's no need to actually staple it, and it's actually a pain to staple them. So yeah, so it's going to be on every single sheet, and you'll have an extra sheet to do work, and you'll also be allowed to have a sheet of written notes. So you can write whatever you want on that too for if you can't remember exactly what does this function do or something. So.
Just to clarify, handwritten?
Yeah, it has to be hand. Yeah. So I have to tell you this amazing story. So in 2017, during the summer, I was teaching this class called CSE 355, Intro to Theoretical Computer Science, and my rule, and it still is true, is you can have any size sheet of paper that you want as long as it's handwritten and it doesn't disturb the person next to you. Okay, so I don't care how big it is, and it still applies here. So, and I have a picture of this, and I can prove it. This one student brought in a literal scroll of paper. So, like it came from, like if he was sitting here, it came out and was hanging literally 2 feet off the edge of the table of where he was working. Barely passed. I'm not kidding. So, yeah, so it has to be handwritten, but do you think I'm just mean by saying it's handwritten, or is there a reason why I say that?
There's a psychological reason for it. You write it down, it's easier to remember.
Yep. So when you write something down, you remember it better than if you just typed it up or just printed something from your friend or something. So that's why I say handwritten, because in my experience, people who handwrite their notes do better on tests. So that's why I say handwritten. But any other questions about the test or assignments or general life?
Assignment part 4, it says for module 4. I don't know what you do.
So let's. Oh, I think I downloaded it. Oh, modulo. Okay. So there's kind of an example written right here. It just means there are 6 pairs to check: AB, AC, AD, BC, BD, and CD. Those are 6 pairs. And then equivalent modulo 4 means if I divide, let's just say I divide A by 4 and I have a remainder of 2, let's say. So it could be like 10 or something. That would give a remainder of 2. And let's say I'm checking the pair AB. If B also gives a remainder of 2, then they are equivalent modulo 4. So if B is 6 and A is 10, then they are equivalent modulo 4. But if B is 7, what is the remainder if I divide by 4? 3. So are they equivalent? No. So is there an operator? So don't answer this. But is there an operator we learned to actually compute the remainder when something is divided by something? Yeah. So this should not be too difficult to do. It's just doing all 6 cases and then printing as the case may be. Other questions? When's the assignment due? Wednesday. Okay. And I promise I'll get assignment 4 out to you this weekend. And by promise, I mean I'll try. But I have a very good idea of what I want the assignment to be. Any other questions about the assignment or tests or whatever? Especially whatever? Yeah.
When is the test?
When is the test?
20.
The 20th, and so roughly how many weeks that is? Almost 2 weeks.
Week and a half.
Yeah, week and a half, 2 weeks, that sort of thing. Other questions? And I put up, I forgot to mention, I put up on the course page a list of the overall topics that I expect to be tested on. You should expect to be on the test. But we'll go over that when we get closer to it. Okay, so last time we were talking more about loops. So what do loops do in general?
It resets the function so it doesn't start the program over.
Yeah, that's true, but more in general, what does it actually do? What's that?
Block of code that runs.
Yeah, it's just a segment of code that we can execute some number of times, 0 or more times. And we couldn't do that before, as was said before, that without starting the program over again, because if else doesn't have a mechanism to go back earlier in the code. So loops allow you to do that. So the first loop we talked about was the while loop, which is really simple. While some condition is true, we do stuff. And if at any point the condition when we check it becomes false, then we exit. You have a question? Oh, okay. Stretching. Let's see. So that's the while loop. If it's when we check the condition is false, we skip. What if we're in the middle of the statements, and at that point in the middle of the statements, the condition becomes false? Do we exit the loop then? No, when do we exit the loop? When we check the condition, okay? The condition could be false at any point during the statement part. It's when we check it that we can actually exit the loop. There's another way we can exit, but we'll talk about that later. Yeah, so the way they exit while loops, you need to have some way of doing that, unless you want an infinite loop. They're mainly used for input validation for while loops because while loops are mainly used for when you don't know how many times the loop will be executed. So if we have some input validator, for example, and we want the user to enter a valid value, could the user just indefinitely put a bad value over and over and over? Yeah, so do we know in advance how many times the loop will be executed? No, we have actually no idea. So, but could the loop be executed 0 times? Like they entered a good value the first time? Yeah, we could skip the while loop entirely if when we check the condition, we just it's immediately false, so we don't even go into it. So while loops are mainly for when you don't know how many times the loop will be executed, and there's a possibility of the loop executing 0 times. I mentioned that because we'll get to a different loop today that does something subtly different. So then we talked about the increment, decrement operators, which is mainly just add 1 to a value, subtract 1 from a value. Super easy. Put them on separate lines, please. Don't do this. It should be illegal, but it's not. Then last time we were talking about these counter variables, which help us know what is the number iteration that we are on. Are we on the first iteration, the second, third, fourth, fifth iteration, etc.? So a counter helps us do that. How did we use counters last time to solve a problem? Yeah, factorial. So how did we use counters to compute the factorial of a number? Yeah, so we had the counter start at 1. We incremented the counter every time we go through the loop, and then we multiply by the counter every single time. So that if we want to go from 1 to n and multiply all the numbers in between, We just start at 1 and multiply by the counter from 1, 2, 3, 4, all the way up to n, or k, or whatever the value we want. But we can do something like printing the squares of numbers. So this is just an example of this where we could start with 1 as our counter, ignore the set w functions, is not important. What is important is that we're using the counter in the calculation itself. So it'll print 1, then 1. Let's just say we're going up to 5. Then we print 2, 4, 3, 9, 4, 16, and then 5, 25. And we increment num every time through. So this is kind of where we were. Okay, I don't know why the display darkens. Oh well. So kind of like the factorial of a number, we could do something called an accumulator or sum. So if I want to compute the sum between some number and a higher number, let's just say 1 to 10, then I start my counter at the lower number, and then while that counter is less than or equal to the target value that I want, I add the counter to the sum, which starts at 0. Because if we don't have any numbers that we've added so far, the sum so far is 0. So we start at 0. And then we add to the counter, add 1 to the counter every time through the loop. If we wanted to add every other number, for example, we would do add 2 to num instead of just add 1. But all the other code would be exactly the same. Okay, so this is where we get to other parts of loops. So a sentinel is mainly a way of saying, we don't know how many times we're going to go through this loop, but if the user enters this special value, we exit the loop. Okay? So it's basically just another word for a condition that says the user has stopped entering input or wants to stop entering input. So for example, if I have an application, for example, that I'm entering your exam scores or something like that, then I don't think -1 is a valid score. So while the points is not equal to -1, then I'm going to keep entering good values over and over and over. And then once I enter -1, I might as well have just said, I'm done entering input. So the sentinel here is the -1 here. So by doing this, we can actually keep track of when the user has stopped entering input. Because we're not really sure what the condition should be, because in general, the points could be arbitrarily big, but they can't be negative. So if you want to have something like this where the user's just going to keep entering input and you don't know how many times they're going to enter stuff, but you know that there's a special value that indicates when they should stop, then use a sentinel like this. So while the inputted value, which is points here, is not equal to the target sentinel that you would say is to stop entering input, then do all the calculation stuff. And then cin at the very end to have them enter again. So if we actually run this, so let's copy this over, make it look nice. So let's just say we have this in here. And then compile our file. Oh, I didn't copy all the lines. Guess it didn't include all the lines in the code. So let's do int points. Then I think that should be okay. Okay, so let's just say I'm entering a score 42. Then it's asking us, because it's not equal to the target sentinel, we're asked to input again. So let's just say 98, 74. And then maybe those are the only scores, so then I should enter -1. And then it'll exit the loop after that. So it's just a way of saying this loop is going to exit when they enter this special value. That's all it means. Oops, wrong slides. Any questions on what's... Again, it's just a target value to say the input is done. So why did I ask before about, or mention about while loops in that we don't know how many times they execute, but could a while loop execute 0 times? Yeah, so what in this case, for example, what if the user enters straight away -1? Does the loop just go ever execute? No. So while loops are good for when you could have 0 iterations of the loop. But what could be an example where we must guarantee that the loop executes at least once? What would be an example? What about a menu application? So if you want to present a menu to the user, should you do that at least once? Yeah, it doesn't make sense to have the menu never display to the user, right? So we kind of want to have a loop that builds this in. So this is an example of a do-while loop. So a do-while loop is almost the same as a while loop, but there are 2 subtle differences. The do-while loop is you execute the loop at least once. You always execute the loop at least once. But the difference, and this kind of implies executing the loop once, you check the condition after the statements, not before. So remember with a while loop, we check at the beginning, then do the statements, and then come back. With a do-while loop, we execute the loop first, then do the condition. Okay? So, like in a menu, for example, in a do-while loop, the very first part of the do-while loop would be presenting the menu, because we want to present the menu. And then sometime after that, we ask for input. And then at the very end, we'll check the condition. Hey, did they enter a right value or whatever we're trying to do? So can anyone tell me the difference between a while loop and a do-while loop? The main difference. Yeah, so while loop, check at the beginning. Do-while loop, check at the end. That's the only difference, other than putting the word do in there and other things. But the semantic difference is while loop, check at the top. Do-while, check at the bottom. Okay, yeah, so because we check at the bottom, we must therefore execute the loop at least once because it checks at the bottom. It continues same way as a while loop is. It's just it checks at a different place. As long as the condition is true, you keep going. If the condition when it's checked becomes false, we exit the loop. Same as while loop. This is a weird anomaly, although it shouldn't be an issue in our class because we're going to always use curly braces, right? Always use curly braces. But in fact, they're required here. So yeah, use do while loops because they're required here. You may have noticed for the while loop part, there's a semicolon after. This one is actually required. So before, when we talked about just while loops, I said that you shouldn't put a semicolon after the while loop part. And why is that? Because there's an empty statement and we can get an infinite loop. We've talked about that before. But here it's actually required because they've decided that that's the semantics of what do while loops do. I'm not sure why, but you do need it there. Okay, so I mentioned that this is mainly purposed for menu-driven programs because we want to display the menu at least once. Could we achieve this with a while loop though, not a do while? This same idea? Yeah, what do you do? Yeah, you do the prompt at the beginning and then you do the while loop afterward. But the issue is that it's a little harder to maintain because you're putting the menu outside of where the loop actually occurs. So it's just a matter of choice here. Personally, if you're going to be doing a menu, do a do-while loop and not a while loop. So for example, if you want to have a menu where you just keep going as long as the user says Y, meaning yes, then what you would have is a do-while loop. Cout, another choice. In fact, there's a bug in this code. Can anyone spot the bug?
Would the menu be displayed like multiple times?
Yeah. Where's the cin statement in here? So if the user, if the choice variable was initially started to be capital Y, what would happen? So like if I did this. Yeah, so like if I did something like this, char choice, ignore the auto cap. So if I did something like this, what would happen? It would always be true because I'm never cinning again, right? So this would actually be an infinite loop. So what is the fix here? Yeah, cin in here. So a cin choice like this. And then now it's correct. So anytime you do a prompt, make sure to put a cin afterward. Is it going to not compile if I leave that cin statement out? It could. It's just a perfectly valid program, but it's not one we want, but it's a valid program. So always do the cin after any prompt. Okay. And then we talked about this before, where we talked about this tuper. I say tuper because it's two upper. Or you can do two lower because we have two different choices here, but that's beside the point. The main point here is that do-while loops are mainly used for menus because you want to display the menu at least once. Any questions on do-while loops? Yeah.
So in this case, would you want to move like the code to display menu outside of the do-while loop and instead repeat the question another choice multiple times? So let's say you
Okay. So yeah, the question is, I think if I understand it, putting the menu instead of inside the do-while loop, put it outside.
Yeah.
That will depend on what you're trying to do. So a lot of the times for assignments, and I think this is on lab 4, if I'm not mistaken, there's an option. You'll be selecting from various options, and one of them is redisplay the menu. So what I would do there, because of that reason, is to put the menu code inside of the loop, because you're going to be asked, you may be asked to print the menu again. But if we're doing something like in and out, so if you go to in and out and you ask what's the menu, what are they going to do? They're just going to point up. Are they going to repeat the entire menu? No. So like in a reasonable application like that, you'll only display the menu once. And in that case, you would put the menu before the loop because it doesn't make sense to print the menu twice or more than twice. So it depends on what you're trying to do. Most of the time, you'll have, so like if you're calling some service and they have like 1 is an option to do this, like change credit card number or something, 2 is this, 3 is this, and then there's like pound or 0, which is to repeat the options. That's exactly this. So I would put any menu code if you're going to be re-showing the menu inside the loop. Any other questions? Okay, so let's talk about my favorite type of loop. And thankfully, this is the last one. So this is something called a for loop. So the main difference here is, there's a lot of difference, but the semantic difference between a for loop and a while loop is a while loop, we don't know necessarily how many iterations the while loop will take, whereas the for loop is mainly used for when we do know how many times the loop will execute. But it turns out that you can convert any for loop to become a while loop and the other way. So you could, in pretty much every case, use either a while loop or a for loop. So it actually doesn't matter which one you actually use. It's just a matter of preference and ease of use of which one is best for each situation. So, but mainly a for loop is when you know how many times the loop will execute. So how does it actually work? We'll see an example of this. So it's kind of like a while loop in that you test at the top, but there's a bit of additions here. So the first part of it is you do some initialization. Oh, by the way, each one of these three parts right here could be empty. So we could do no initialization or no test or no update. But most of the time we'll be doing some initialization code. And we'll see an example of what that actually is. So yeah, we'll talk about that in a second. Then the usual test condition. So the condition from before with while loops and do while loops, that's the same thing with test. That is exactly the same. Update is when you want to do any updates to the code or some value at each iteration in the loop. So remember with while loops, we had these counter variables and we were adding one every time. That would be an example of an update. So you would put an update in the third section right here. So, and then on the inside is just usual code, nothing special. So it's like a while loop in that you test at the top, but you have some initialization if you want, and some update if you want. So what does this actually look like? So, what you would do usually is you have some initialization code right here. So I'm initializing some variable. It could be a new variable if you want, or it can be an existing one. In this case, it is existing because I don't have int or whatever in front of it. I'm initializing count to be 1, so I'm initializing something. The condition is while count is less than or equal to 5, and then at each iteration in the loop, I'm going to add 1 to count, every single loop iteration. So what is the order of when things are checked? The initialization is always done first before the condition's even checked. So before the condition even checks, we're doing the initializations part. So then, like a while loop, it then checks the condition right away. Then it doesn't do the update. It does the statements inside the loop first. And then once it comes down and does those, before it comes back up and checks the condition again, it does the update first. So the order is init, check the condition, do the statements, and then do update. And then it repeats check, statements, update. Check, statements, update. As long as the condition remains true. So let's actually step through. Let's see. So let's open this. So let's see. So I actually can't select it, but count equals 1, count less than or equal to 5, count plus plus. I'll make this a little bigger. And then cout hello. I'll make it /n to make it easier to read. Okay, so let's just say int count was equal to 0 before the loop, and then we initialize it or give it a value at least in the initialization part. So let's step through this. So let's look at what is the output before the loop even begins. Assume no couts before. Nothing. We haven't printed anything. So let's see. we come down here. What is the first part of the loop? What do we do first? The initialization part. So let's keep track of count value, which is now 1. And then what do we do next? After doing this, evaluate the condition. Is it true? Yeah, it's true. Perfect. So then we see out hello. So we print hello with a new line. I don't know what it did there. So we print hello. Now what do? We do the update part. So then count's value becomes what? 2. And then now is the condition true? Yeah, so it's true again. So we print hello, and then we come down. Then we do the update again. Count's value becomes 3. Good. And then obviously we're going to print hello. So let's just say we do it 4 times. So let's just say count is 4, and we've printed 4 times now. So we've went through the loop 4 times. We're coming back up. Count becomes 5. Is the condition true? Yes. I'm going to make this bigger. So then we go through the statements again. Hello. And then, so we print new line. Now what do? Oh, we don't exit first. We do the update. So before we even do the condition, we always do the update. So then we do the count plus plus. Oh, it was 5 before. Now it becomes 6. And then now what? Then we exit the loop. So because 6 is not less than or equal to 5. So if I couted count right here, what would I print? 6. How many times did we go through the loop? 5. So here's an example again of where it could be a off by 1 error. Even though we went through the loop 5 times, we still get a value of 6. So just be careful of that because of this side effect right here. What could be a way that we could avoid this? Suppose we didn't actually need to know the value of count outside the loop. What you could do instead is, if I only need count inside the loop and I don't need it anywhere else, you can actually declare the variable right here. So this is actually what is very common with for loops, where you declare the variable right here in the initialization part. You don't declare it before like you would a while loop. So I prefer this loop because of this, mainly, because I don't have to declare a variable before and then give it a value at the start of the loop. I can just do it all in one, and it makes the code a lot cleaner. And it's convention too, which is nice. But any questions on how that actually worked? And just the method of executing through. Okay. But it's very similar to a while loop, track of some things sometimes. So here's an example of this. So if we want to add the numbers from 1 to 10, we saw an example with a while loop before, but we can, of course, do it with a for loop here. So if we want to add the numbers between 1 and 10 inclusive, then we start from 1. I could declare num. So look at this. Do I need to know the value of num anywhere but where the loop is? No. So what I could do then is just initialize num right here in the for loop. Do I need to know the value of sum anywhere but the loop? Yeah. I need the value of sum after the loop, so it needs to be declared before the loop. Interesting example of scope. So what is scope? Well, where variables can be accessed, right? So this value, this integer num right here, when it's declared like this right here in the for loop, you might as well just assume it's only available inside the for loop. It's not available on the outside. Whereas the sum variable can be accessed inside the loop and afterward. So you just gotta think, do I need this variable outside the loop? If not, then I would declare it inside the loop. If you do need it, then outside the loop you go. Oh, by the way, what if I wanted to know the sum of numbers that that are 1, 3, 5, so all the odd ones, starting with 1. What would I change about this loop? Yeah, so I would do plus equals 2, or if you want to stick with the old format, you can do this. So I can do exactly one change to the code, and then now I've changed it to the sum of odd numbers between 1 and 10 versus all the numbers. So again, so a for loop and while loop are the same. So when I say that, are you convinced that for loops and while loops are the same? Like I can convert any for loop to a while loop? So here's a little lesson. So this is what we mathematicians call proof by intimidation. So I say this in loud voice and convincing voice that this, and it seems intuitive that this is true. Is that convincing? Okay, so some of you might be convincing, but should it be?
No.
So like when someone on TV says something that seems obvious and like you agree with it, should you agree with that automatically just because like you respect the person or whatever? No, you should trust but verify. Verify that that is actually true. So in our case, we want to verify, are they really the same? Or are there some things that a for loop can do that a while loop can't, or the other way? So let's just say that we have a while loop that has some condition and it has statements. How can I convert this to a for loop that does the exact same thing? So I need a for loop with the parts, the 3 parts, and then obviously I'm going to have the statements in here. What should I put in the 3 parts? Sorry? I don't have to. So I need to have 2 semicolons here. That's just the syntax. But I can leave the first and second and third part like this if I wanted to. So what would I actually do though? Yeah, leave the last part blank because the statements in here, if they're updating, I'm going to be updating in here. So there's no issue there. So I'm going to leave this part blank. What about the other 2?
All you have to do is put the condition in the middle.
Exactly. That's all I need to do. What about any update? Not update. Initialization. I don't need it because the while loop, if it needed an initialization, was done before the loop. So in fact, any while loop can be converted to a for loop. But is that convincing that they're equivalent?
Yes.
Could there be something that a for loop can do that a while loop can't? Well, let's see. What we've shown here is that everything a while loop could possibly do, we can make a for loop for it. But could it be possible that a for loop could do something that a while loop cannot do? It could be. What do I need to show that that's not the case? Right. So can I convert any for loop into an equivalent while loop? So what we've shown here is that every while loop can be converted to a for loop. But that does not show the other way that any for loop can be converted to some while loop. So let's actually show that. So let's just say we have an arbitrary for loop. So we have some init conditions here, condition and then update. So this can be any loop at all. Any for loop at all. We don't know anything else other than it has an init condition update. Can I convert this to a while loop? What would I do? Well, let's see. Well, I need a while loop for sure with stuff in there, and then it's pretty obvious I'm going to put statements in here. There's no issue about that. What would I change though? Exactly. I need the init first because init, remember, for a for loop occurs before the loop even does anything else, any conditions, anything. So we put init on the outside. What else? What about the condition? It goes in the condition, so that's not hard. Now let's think carefully about the update. Where should the update go? So it's going to go inside the loop, but should it go before or after the statements? After. Why? Right. Think about how a for loop works. It does condition and then it does the statements. But then before it comes back to check the condition, it does the update. So when should we do the update? After the statements and before the condition of the while loop. So we have to put it down there. So in fact, what we've just shown is that they really are the same. They can do the same thing. So it doesn't really matter whether or not you use a while loop or a for loop. Great test question, by the way. Could you convert this for loop into an equivalent while loop? But the important thing to take from this is that there really is no difference between the loops other than convenience or convention or whatever the case may be. So from the structure of a for loop, because we have this update, it seems like they are mainly used for when we know how many times the loop will be executed, because we have an update explicitly here. And with a while loop, there isn't one, so it's mainly for when we don't know that. But because we can leave 1, 2, or all 3 of these parts out of the for loop, then I can simulate one with the other. So it's just mainly about convenience. That went. Proofs are fun. All right. Let's see. So I think we talked about most of this. If the test condition is false the first time, it'll, just like a while loop, it skips everything. The update expression can increment or decrement by any amount. It actually doesn't have to update or increment or decrement. It can do some wildly other code. And do is actually pretty astonishing sometimes. So what you could do in a for loop, for example, let's actually copy an example down. So let's print this. So what you could do, and I'm going to be a good citizen. Okay, so what you could do in each of the parts, in the first and the third part, the init and the update part, not the middle one, is you can put a comma to separate multiple things. So if you want multiple statements on one part, then because the semicolons are used for the separation of the 3 parts, we can't put a whole statement in there because it ends with a semicolon and it can't tell the difference. So a comma is commonly used here. What we could even do sometimes is we can put a comma and then do some other code, like points plus equals 2. So by putting a comma here, I can actually do multiple things in the same update part, which is kind of weird. We usually only do one thing in the update part, but sometimes you need 2 of them there. I don't know. I was thinking the same thing. Let's see. So let's just do hello world. That'd be weird. I've never seen that. Oh, that's really interesting. I've never seen. I learn something every day. So yeah, you can do weird things like this, which makes me smile. So if you want to do, for whatever reason, put multiple statements in the update part, put a comma separating them. And there's no need for a semicolon because they're used for the spacers here. Okay. Yeah, that's when I want to talk about that. So let's look at this third point. Variables used in the initialization section should not be modified in the body of the loop. Could they, though? Yeah. So this is just a convention. So if you have some loop counter variable like we've done before, it doesn't really make sense to update it inside of the statements part. It makes sense to update it in the update part. So if you have things that are initialized and you want to update them, put them in the update part for if you're going to be using a for loop. It's just sort of common sense. All right. Yeah, separate with commas. This is just what we talked about before. You can omit one or all three if you want of the parts of the for loop. Yeah, so you can omit things if you want. So which loop should you do? While loop is if you want to test at the top and you don't necessarily know how many times the loop will execute. Do while is the same thing, but it tests at the bottom. And the implication of that is that the loop executes once because it's got to go from the top to the bottom, so it must execute at least once. So it depends on which use case you have. By the way, do while we've just learned executes at least once. Can any while loop be converted into a do while loop because of that? Could while loops execute 0 times? Yeah. Can do while loops execute 0 times? No. So there must be something that a while loop can do that a do while loop can't do. What's that? There are mechanisms to deal with that. For example, you can put a break statement in a do while loop, but barring all that, there are things that a while loop or for loop can do that a do while cannot do, ignoring the break and whatever. For loop is, again, a pre-test loop, but is mainly used for when we know exactly how many times the loop will execute. So for example, remember the example where we had the user enter a number and it prints 1, then the square of the number, 2, then the square of 2, and then etc. up till the user's value. So if they entered 15, it would go to 15. Do we know exactly how many times we'll execute? Do we actually know, though? The user entered the value. So if they entered 15, do we know that the loop will execute exactly 15 times? Yeah. So there we actually do know how many times we'll execute. In the case of keep asking input until the user enters the right value, do we know how many times that will take? No. So it's a matter of preference, as we've discussed many times. All right, so one more slide, hopefully. So we've talked about loops. Sometimes, and I've seen this many times, you want a nested loop. So for each iteration of the outer one, you want to do all of the iterations of the inner one. So let's just say that you want to print a times table. So if we have like 1 to 10, 1 to 10 as rows and columns, then what we could do is print the first row, and that'll be the inner loop, and the outer loop controls which row we are at. So the outer loop says, we're at row 1 right now. The inner loop is going to go over all of that first row. And then once we're done with the first row, we go down a row and then do the entire thing again. And then again, and then again, and then again, until the outer loop says, I'm done. And in fact, in my experience, I've seen a 6 nested loop before. So these can actually get really deep. So deep. Yeah, so the inner loop goes through all iterations of the outer one. Inner loop completes iterations faster because it does all of its iterations for one iteration of the outer one. And so we'll talk about this next time. So I'll see you all on Monday.